So I'm going to do the Kaggle courses again and think about which one I'm gonna start first. I wanna do the data cleaning, I guess. Data cleaning, pandas, future engineering, and then maybe the machine learning ones, but I'm not sure which one. Because I had trouble initializing the machine learning thing at the beginning, doing the split, the data set split, and cleaning the data, doing that stuff. So I think I'm gonna do the data cleaning first. And I think before I go back to reading the book again, I'm gonna probably finish these courses again. Not sure if I'm gonna go over all of them entirely, or just the parts that I think that might be interesting to review. So let me put an alarm here because I think I'm gonna stay 1 hour here today, and then I'll probably continue tomorrow doing this stuff. Maybe I spend more time today, but we'll see. So take a first look at the data. First thing to do when you get a new data set is to take a look at some of it. So use the head to take a look at the data set. How many missing data points is no.sum. Maybe I should study the things that I wrote down on the notebook as well. The methods and the libraries. But I think I might do that after I do the Kaggle courses. I'm gonna probably do open up the IDE, either Visual Studio or PyCharm, then import all the libraries that I want to study, and then I'm gonna use the inspect module to search the functions inside of them, and then maybe look at the documentation as well while I do that. Figure out why the data is missing. This is the point at which we get into the part of data science that I like data intuition. So I think this is relevant. Drop missing, not irrelevant, but not important when it comes to coding because it's more to do with the other parts of just thinking in physics in general. Drop missing values, drop an A. I think we're gonna try to jump on the exercises right away and see how many I can do before looking at the tutorial again. And I think it's much better to do it with the black background, honestly. So this was very useful to know with this dark reader extension. Questions below will give you feedback on your work. Run the following cell to set up the feedback system. Yeah, the only drawback is that sometimes this thing doesn't work. When I'm trying to update the YouTube videos, it doesn't show which box is highlighted when I have this dark reader turned on. But yeah. Take a first look at the data. Run the next code cell to load in the libraries and data sets you use to complete the exercise. Part pandas, numpy, and then reads the data set and creates a random seed. Set seed for reproducibility. So this is so you maintain the random values. You're capable of reproducing the same random values every time. Use the code cell below to print the first 5 rows of the SF permanence data frame. So I'm not sure if this has run. I'm gonna try to run it. Yeah. So it shows have any missing values. So yeah, there's a lot of here missing values. Check your answer, run this code. First 5 rows of the data frame of the data that showed that several columns have missing values. How many missing data points do we have? What percentage of the values is the data set The data set are missing. Your answer should be a number between 0 and 100. If one fourth of the values in the data set are missing, the answer is 25. Should do here. And total NP drop products. So I'm not sure if this is the thing that I've done and it's saved here. This might be a problem. But I don't remember this np.product here, just the isNode.sum. Missing divided by total. Yeah, I think it's all done because I already did the courses. That's a shame. Wonder if there is any way that I can delete this. Not sure if redo is the right word. Which reset lessons? In Chicago programming in general, I decided to fiddle with the page in one of the lessons, and I can't find any way to reset all the code. I've erased all the data sources I removed from the draft environment. Just clean states, what I'm trying to get. Recompose Kaggle. I'm gonna take this off because it's really it's kind of hot here, and this thing is too tight. All these steps should delete script page on kernel or kernel that you've accidentally damaged. Go to your Kaggle profile, code, your work, check which file you need to remove, delete. I think I'm gonna change the screen just to make sure that I don't accidentally show something that I can't. So profile, code, your work. I think I found it. Where to put it in the notebook. So I think I'm gonna delete all of them because I don't really care about the certificates because I already have it on stream and on film myself doing all of them. So it doesn't really matter. I wonder if there's a easy way though to delete all of them. Yeah, I think I'm gonna delete. I'm gonna put it on white again because it's forcing my eyes. But I'm not sure if this is deleting this stuff. Seamless doesn't. If it doesn't let me do it, then I'm just gonna go over the courses again and study the other stuff. So isno.sum.sum. And total is np.products.product sf permits.shape. I'm not sure if I understand fully what this line does. I guess NP dot product is pretty self-explanatory, but I don't understand this taking the product of the shape. Maybe it's getting the whole data frame there, all the values in the data frame, and then dividing this by the missing by total to find the percentage times 100. So I guess that's what's happening, but I don't understand the methods. So maybe I'm gonna jump on future engineering to remember how to do how to rescale the data. I don't remember if this is this on this one or the clean data cleaning course as well. So I guess this is the most recent one. This thing is on. It's really hot here where I live. Generally follow the Google Developer Documentation Style Guide. NumPy style governs cases where Google has no guidance, or we prefer choose Google style. Using Sphinx in combination with the NumPy conversions, you should use the NumPy doc extension so that your doc strings will be handled correctly. Use NumPy API and reference docs. So honestly, I really don't like the way that these things are done. It's kind of confusing to see where the functions actually are and how to research them. No information about arrays. Turn the product of array elements over a given axis. Parameters A array like. None are int or tuple of ints, optional. X's are axes along which a product is performed. The default axis equals none. We will calculate the product of all the elements in the input array. If axis is negative, it counts from the last to the first axis. If axis is a tuple of ints, our product is performed on all of the axes specified in the tuple instead of a single axis or all the axes before. The type of the return array as well as the accumulator in which the elements are multiplied. The D type of A is used by default unless A has an integer D type of less precision than the default platform integer. In that case, if a is signed, then the platform integer is used, while if a is unsigned, then an unsigned integer of the same precision as the platform integer is used. So I guess it does exactly that I was thinking about. It just gets the shape of the array and multiplies the rows with the columns to find the whole dimension. And then the other one finds the amount of no values and divides one by the other, and then multiplies by 100 to find the percentage. The goal, a guiding principle of future engineering, concrete formulations. I think it was on data cleaning, actually, to rescale the data. I'm gonna come back and then. I think I'm gonna do an overview of these courses only, not do them again. That way it's probably going to go a lot faster, and then I can start studying the libraries themselves and the functions and trying to explore how the functions work. Another thing that I want to study that I saw, which is something that when I was briefly looking at the libraries on TensorFlow, I think I saw some decorator functions, and wasn't sure what that was. And then I researched that. Eventually, I don't remember how, but I had some question. Then I started researching, and I got into a video that talked about decorator functions, and I thought that was really interesting. And so far, I haven't studied about that, and it looked really confusing. So I think that might be a useful stuff to read about. Also about classes, which is something that I found very difficult because I don't have a lot of not very difficult, but I don't have a lot of experience building them and done their methods as well. And it seems like any library has these functions and classes with done their methods and decorator stuff. How to convert a 1D array into a 2D array. How to add a new access to an array. You can use np.newAccess and np.expand dims to increase the dimensions of your existing array. Using np.newAccess will increase the dimensions of your array by one dimension when used once. This means that a 1D array will become a 2D array, a 2D array will become a 3D array, and so on. Because np.newAccess to add a new access. Cool. Indexing and slicing. You can index and slice NumPy arrays in the same way you can slice Python lists. Yeah, the issue is that the documentation of the things it's not really enough for me to satisfy my curiosity. Because I want to understand how the things work and not necessarily which methods to use. Because once you understand the dynamics behind it, then everything becomes more intuitive when you're thinking about the solution you're trying to get. And it's all about finding the best solution. But obviously the methods are important as well, because if you don't know the methods, then you have to research all the time. That decreases the efficiency when you're solving the problems. You can pass Python lists of lists to create a 2D array or matrix to represent them in NumPy. So this creates a matrix. Indexing and slicing operations are useful when you're manipulating matrices. So this creates a 2x2, 2x3 matrices. The rows are each list, and the columns after the comma. You can aggregate matrices the same way you aggregated vectors. Like one thing that I'm curious about is I wonder where the distinction between NumPy arrays and pandas data frame came about, because it seems like they do the same thing but in different ways. So pandas is basically separated by comma. Each column and each row is gonna be values separated by comma, and NumPy array seems to be lists of values separated by comma, which is a different structure but it's very similar. And from what I've researched so far, NumPy's array seems to be more efficient and faster for some things. Generating random numbers. The use of random numbers generations is an important part of the configuration and evaluation of many numerical machine learning algorithms. Whether you need to randomly initialize weights in an artificial neural network, split data into random sets, or randomly shuffle your dataset, being able to generate random numbers, actually repeatable pseudo-random numbers, is essential. Generator.integers, you can generate random integers from low. Remember that this is inclusive numpy to high exclusive. You can set endpoint equals true to make the high number inclusive. How to get unique items and counts. You can find the unique elements in an array easily with np.unique. Use np.unique to print the unique values in your array. So that's good to know. To get the indices of unique values in NumPy array, an array of first index positions of unique values in the array, just pass the return index argument in np.unique as well as your array. np.unique, a return index equals true. To get the indices of unique values in NumPy, an array of the first index position of unique values in the array, you just pass the return index. So this gets the index of the unique values. This is useful to know. You pass the return counts arguments in np.unique along with your array to get frequency count of unique values in an NumPy array. So this gets the frequency. This also works with the arrays if you start with this array. You can find unique values with this. So np.flip to reverse the array. Once you print your reversed array, you can run reversing into the array. Maybe you should try to memorize this stuff by making a list of them and then trying to build the programs and check and put the comment of a description of what it does and check to see if I got it right. That could be a good exercise as well. Reshaping and flattening multidimensional arrays. There are two popular ways to flatten an array, .flatten and .ravel. The primary difference between the two is that the new array created using ravel is actually a reference to the parent array, a view. This means that any changes to the new array will affect the parent array as well. This ravel does not create a copy, it's memory efficient. So ravel affects the both. If you start with this array, np.array, use flatten to flatten your array into a 1D array. When you use flatten, changes to your new array won't change the parent array. Okay, but when you use ravel, the changes you make to the new array affect the parent array. So maybe this one is a good one to know for when I want to do machine learning stuff. It's probably gonna be useful sometime. Yeah, travel. How to access the docstring for more information. When it comes to the data science ecosystem, Python and NumPy are built with the user in mind. One of the best examples of this is the built-in access to documentation. Every object contains the reference to a string, which is known as the docstring. In most cases, this docstring contains a quick and concise summary of the object and how to use it. Python has a built-in help function that can help you access this information. This means that nearly anytime you need more information, you can use help to quickly find the information that you need. But how do I use this? Help max. Help on built-in function max module built-ins. Max iterable value. So just use help and then type the function. Because access to additional information is so useful, Python uses the question mark character as a shorthand for accessing this documentation along with other relevant information. Python is a command shell for interactive computing in multiple languages. You can find more information about IPython here. LPython, IPython. So this, you can even use this notation for object methods and objects themselves. Let's say you create this array. Then you can obtain a lot of useful information. First about a self, the array. So I think the question I have is how to do the trains and train test split. And there's a lot of stuff here. That's the problem. And I want to know everything, with not a lot of time. I think it's getting dark here, so I'm probably gonna turn on the lights soon. How to split train test set with scalar. I guess it's just a function, right? X train splits. Get the location, split the data set. X train, X test, Y train, Y test equals train test split. X, Y, test size 0.05, random state equals 0. So I think what I'm gonna try to do is open the IDE and try to do this stuff, maybe. Yeah, I'm gonna turn on the lights as well. So let me see if I open. Well, I think I'm on the page of the Kaggle exercise. Yeah, the house pricing and stuff. So this is from the book that I'm reading about Keras and Escaler. Save housing the copy. I think I'm gonna create a new file here on training. Rename. How can I open this with Jupyter Notebook? Parts. Sklearn. Dot pre-processing. I think it was something like this. I don't remember really well. Also, I have to see how do I increase the size of these letters. I'm gonna open up the settings and see if I can do it. Font size 20. Yeah, much better. Sklearn.linear model. I actually didn't do anything. I remember I had to do something like from my sklearn import train test split, something like that. Then I get the data. Well, that's the problem. I have this housing info here. They read SV housing info.csv. Then X is gonna be, I think it's caps lock, but I'm not really sure. df.ilock. I'm gonna get all the rows up to the sum column. I don't remember how many columns this dataset has. Let's say 3. That's the thing then. I think Y is gonna be df.ilock. I'm not really sure. From 3 to 7. And I have to import pandas as well. Print. I think this opens up a Jupyter Notebook here. It's probably gonna be better to test. Single position indexer is out of bounds. So it's this one. So let me see how many I can't change. This is annoying. It's slightly different than the normal Jupyter notebooks. So this doesn't show the columns of the data frame. If I do it like this. Hmm. Yeah, so X with caps lock, Y. But it's getting from all the rows, pretty much. So -1. It's the other way around here. Then I'm gonna do X string, X test. Guess it's caps lock here as well. X train, Y train. Yeah, X test, X train. Now string dot. Nah, don't remember now. What should do? Maybe string test split, something like that. Doesn't make much sense. Oh, here's Y test. String test split. So I got it right, I think. String test split. It's X, Y, and then I forgot as well. But I think then is the model. Test size 0.05. So this part I don't understand. If I'm dividing the data before, why do I need test size 0.05? I don't get it. This is the hard part of understanding machine learning. It's not the application of this thing. It's actually understanding how things work behind the scenes. Because nobody talks about how they work. They just talk about how to implement the functions. Random state. Train test split's not defined. So that's the problem. I think I have to import this. Here is not showing that it's imported. So maybe it comes from this module already. The linear regression module. We just copy this code and see if it works. Yeah, it doesn't work here. Oh, it's because of the file. Maybe now it will work. The train test split is not defined. Yeah, so the example they gave is kind of wrong. So let's try before I research again. If it doesn't show there, it's probably not gonna work. So maybe we'll do this another time because it's probably better to separate the time to do the inspect and stuff. I'm just gonna keep going through this and give a brief overview of what I done before. Figure out why the data is missing. Look at the columns street number, suffix, and zip code from the San Francisco building permits dataset. Both of these contain missing values, which if either are missing because they don't exist, which if either are missing because they weren't recorded. Drop missing values rows. So drop NA drops missing values on rows when the axis is 0, and on columns on the axis is 1, I guess. Yeah, so I didn't load the initial stuff. That's why it's not recognizing the data frame here. Drop missing values columns. So F drop NA axis equals 1, drops columns. Here gets the shape with NA shape 1. Cause NA dropped. Filling missing values automatically fill NA. Method equals bfill. Try replacing all the none in the SF permits data with the one that comes directly after it, and then replacing any remaining nones with 0. That results in a new data frame. More practice. So I'm gonna keep going on this. So the method that I remember for scaling is mean and max scaling. But I saw this on the video. I didn't remember from the course. So let's see if that's the one they use on the course. So pandas, numpy, scipy, mlex, then preprocessing, part min max scaling. I don't remember how it works exactly as well. Scaling versus normalization, what's the difference? One of the reasons that it's easy to get confused between scaling and normalization is because the terms are sometimes used interchangeably. And to make it even more confusing, they're very similar. In both cases, you're transforming the values of numeric variables so that the transformed data points have specific health properties. The difference is that in scaling, you're changing the range of your data, while in normalization, you're changing the shape of the distribution of your data. So this is important, I think, to remember. I think I'm gonna write this down here so I remember later. It might be better to just save in this format instead. I'm gonna put more information here. Useful VPN pandas. Scaling, you're changing the range of your data, while in normalization, I'll put this on like this. changing the range of your data. So you're making the values, you're keeping the distance between values, let's say, but you're changing the amount in which they vary. So if you have values varying from 0 to 100, you're maintaining the integrity. Not sure if that's the right word, but maintaining the core, the essence of the data, but changing the scale from 0 to 100 to 0 to 10 or 0 to 1. Normalization, you're changing the shape of the distribution of your data. And normalization, you're actually changing the amount that the things vary. Which is kind of, so I think from this I prefer scaling intuitively to maintain the essence of the data. Because scale is always relative, but the relationship between things, if you change the relationship between things, you risk losing more core information, in my opinion. Scaling, this means that you're transforming your data so that it fits within a specific scale, like 0, 100, or 0, 1. You want to scale data when you're using methods based on measures of how far apart data points are, like smart vector machines or k-nearest neighbors. With these algorithms, a change of 1 in any numeric future is given the same importance. For example, you might be looking at the price of some products in both yen and US dollar when US dollar is worth about 100 yen. But if you don't scale your prices, methods like SVA, yeah, is not important. So the method here creates a random distribution of explanation data with size 1000 points randomly drawn from an exponential distribution. Min-max scale the data between 0 and 1. So just call min-max scaling, and then you import the min-max. I think it comes from SciPy library. No, from MLX stand preprocessing import. So I'm gonna put this on the libraries to study. This is the list I have so far. I think I'm gonna go by this order here. So maybe I put this, I'm gonna put this before the other ones because they're currently more important. Maybe I should put NumPy and pandas as well before all the other stuff. I kinda wanna study more about SciPy though. Where was I? So it parts from this library and just calls it there. And then puts the original data columns 0. Plot both together to compare. So I guess you can only do it one column at a time, maybe. Notice that shape of the data doesn't change, but that instead of ranging from 0 to 8ish, it's now ranges from 0 to 1. Scaling changes the range of your data. Normalization is a more radical transformation. The point of normalization is to change your observations so that they can be described as a normal distribution. In general, you normalize your data if you're going to be using a machine learning or statistic technique that assumes your data is normally distributed. Some examples of these include linear discriminant analysis and Gaussian naive Bayes. Pro tip: any method with Gaussian the name probably assumes normality. The method that you're using to normalize here is called the Cox Transformation. Let's take a quick peek at what normalizing some data looks like. So it's from this SciPy stats library. Cox. So yeah, I guess these are the libraries that I have to study a lot more in depth because they seem to be very useful. So far, the things I've used the most are NumPy, pandas. Pandas probably the most, then second NumPy. and then SciPy a little bit, and Matplotlib, and then obviously machine learning stuff, which is TensorFlow. Question below will give you feedback on your work. Run the following to updates, okay? Get an environment ready. Kickstarters, min-max scaling, original data columns. Yeah, so you can only do it one column at a time, and probably if you want to do it on all of them, you have to create a function and then call the function on a loop to replace each column and apply the min-max scaling to each column, and then rewrite the data frame using CSV, chew_CSV, which is also something that a lot of people don't talk about. Like, to actually rewrite the data frames, you have to put chew_CSV at the end, and that's gonna restructure the data frame, replace the values that you changed, which is somewhat confusing for me as well. So I guess this is done. Yeah, so it's only using min-max scaling here. Practice scaling, min-max scaling, then the column. And the other is just stats.boxcox positive plunge. Yeah, next one. So this is just about the dates, I think. This doesn't work, by the way. When you have UTC format, you have to change to this format before, and then this it's only useful when you already have data that is on kind of date format, but it's considered as object, as a string, not a date format. Select the day of the month. Yeah, date time is also another library that might be worth looking at, but I don't think is that important. Select the day of the month to check the date parsing. Yeah, this is not very important. It is important, but what they talk about there is not really useful from my experience. It's more useful knowing how to transform from UTC to date formats and from date formats to UTC, because APIs usually translate the date time to UTC because it's easier to transfer the numbers from networks in UTC format. I guess. I'm not really sure about that, but so date times, just gonna talk about the date time stuff. np.where seems to be useful. I'm gonna have to look at that later. Probably gonna do the inspect stuff tomorrow, I guess, to look at these libraries and their functions. Yeah, here's opening up another one. Helpful character encoding module. This one is also useful. So the thing I don't understand, not very good about categorical columns is how do I merge the categorical columns at the end after I encoded them? That's a little bit confusing to me, because I get afraid of wasting the original data frame when I'm merging together again. It's kind of confusing to know how to merge and how to rewrite the data frame. Character encodings are specific sets of rules for mapping from raw binary byte strings that look like this to characters that make up human readable text like hi. There are many different encodings, and if you try to reading text with different encoding than the one it was originally written, you end up with scrambled text like Add this. Parent encoder mismatch less common today. There are lost characters. It was pretty hard to deal with encodings in Python too. Oh, so this is not talking about the thing that I was actually talking about, which is one hot encoding for machine learning. Just talking about the difference in formats. So that's probably in another course. I think it's probably on the intro to machine learning stuff here. You start with an overview of how machine learning model works and blah blah blah. Machine learning works the same way. You start with a model called this decision tree. There are fancier models that give more accurate predictions. Decision trees are easy to understand. For simplicity, we will start with the simplest model possible decision tree. So if pass goes here, if doesn't goes here. Which of the following two decision trees is more likely to result from fitting the real estate training dataset? Yes or no to fit two problems, then predict the price. So this one's probably correct. Decision tree from the left probably makes more sense because it captures the value the house is more better on somewhere. Capture more factors using a tree that has more splits. These are called deeper trees. Decision tree that also considers the total size of each house. Houses lot might look like this. So I think I'm gonna skip this one here. It's kind of hard to know because there's so many things that seem like a waste of time. But then if you don't accept that you're gonna waste your time on some of these things, you might miss the important ones. That's the problem. Because I hate wasting my time on this stuff that it's kind of uh, it seems like they just put it there just to put it, but it's actually not that useful. Part woozy. Yeah. So this is just the string manipulation. Yeah, this is the end, so that's not the course. Pandas, describe, next. It's probably intermediate machine learning where they start talking about categorical columns. Building our model. Yeah, it's gonna be on the intermediate one. See how much time I have here. It's almost already 1 hour. There's model validation. Yeah, here. Scikit library has a function train test split to break up the data into two pieces. Use some of that data as training data to fit the model, and we use the other data as validation data to calculate mean absolute error. Here's the code. So it's train test split from sklearn model selection. Let me copy this stuff and see if it works. Model selection. Train test split. doesn't work, then it's probably a problem with my IDE, Visual Studio Code. Yeah, now it works. So the thing is, you have to import from the right library. So I guess if you wanted to do like if you want to import from sklearn, then you probably have to do it with model selection dot train to split, and then it's probably gonna be the same thing. So sklearn. Oh, oops. Is import here, not from. So it still doesn't work. It's not defined. Because this dot access the directory, which the thing is. Yeah, so I have to, well, but that's, maybe I have to type sklearn then model selection. Yeah, probably that's the thing that I should do. Because then it's gonna access the folder. Hopefully it works. Yeah, now it works. So it's obviously a lot easier to import from model selection. So the thing is, you gotta know which folders each of the imported things are. This is not that hard actually. First, you separate the data and put your x and y. Then you do, I forgot the name of this stuff, where you make a bunch of variables equal at the same time. I think it's the factoring or something like that. Make this and then you assign to this. But I still don't understand what this test set is. Random state is just to do it at randomly, to split the data randomly, and to do it every time the same way. But the size, I'm not really sure. I think I'm just gonna go through the end of this one, and then I'm gonna, I forgot to update this. Then I'm gonna see if it's on the intermediate machine learning that there's this stuff that I wanna know. I'm probably gonna use the inspect thing tomorrow. Yeah, I wanna see these functions here also. So sklearn metrics, part mean, absolute error. So everything is from sklearn metrics. I'm probably, yeah, what I'm gonna do is create a file with these things here. Because the first thing that I wanna do is study TensorFlow and Keras. Maybe I should put sklearn here. So yeah, tomorrow I'm gonna use these inspect functions here, search for this, and I'm gonna create a folder just to do this. So yeah, probably tomorrow. If not tomorrow, then the other day after tomorrow. So see ya.